Colloids. Colloid is a homogeneous non-crystalline substance consisting of large molecules or ultramicroscopic particles of one substance dispersed through a second substance. The particles do not settle, and cannot be separated out by ordinary filtering or centrifuging like those in a suspension. Tyndall effect. The phenomenon of scattering of light by particles in a colloid or in a very fine suspension is called Tyndall effect. The individual suspension particles scatter and reflect light, making the beam visible. The amount of scattering depends on the frequency of the light and density of the particles. As with Rayleigh scattering, blue light is scattered more strongly than red light by the Tyndall effect. Glass is a non-crystalline, often transparent amorphous solid, that has widespread practical, technological, and decorative use in. It is solid in solid colloidal solution which behaves as a pseudo-solid. Glass might seem to be pure with naked eyes, but gives a very mild Tyndall effect when light is passed. An alloy is a mixture of chemical elements of which at least one is a metal. The hardness or strength of the overall compound increases significantly. The picture shown here is a bangle made of gold alloyed with bronze, which is a solid in solid colloid. Paint is any pigmented liquid, liquefiable, or solid mastic composition that, after application to a substrate in a thin layer, converts to a solid film. It is a solid in liquid colloidal solution, in which solid pigments are dissolved in a soluble liquid. Glue is an adhesive which is applied to one or both surfaces of two or more separate items. Adhesive property is due to strong van der Waals forces of attraction. It is a solid in liquid colloid, in which mainly polyvinyl acetate is dissolved in water, ethanol, and acetone. Dust is made of fine particles of solid matter. It generally consists of particles in the atmosphere that come from various sources such as soil lifted by wind, volcanic eruptions, and pollution. It is a solid in gas colloid, in which dirt and other particles are dispersed in air. Incense stick ash is the byproduct of lighted incense sticks. The ash is rich in calcium, magnesium, aluminum, and silicon. It is a potential candidate for the formation of calcium-rich zeolites. It is also a solid in gas colloid, with economical elements in solid powdered form dispersed in air. Cheese is a dairy product produced in wide ranges of flavors, textures and forms by coagulation of the milk protein casein. It is a liquid in solid colloidal solution, in which whey is dispersed in protein and coagulated fat. Butter is a dairy product made from the fat and protein components of churned cream. It is a semi-solid emulsion at room temperature, consisting of approximately 80% butterfat. It is again a liquid in solid colloid, in which butterfat is dispersed in milk solids. Milk is a liquid in liquid colloidal white fluid consisting of minute globules of fat suspended in a solution of casein, albumin, milk sugar, and inorganic salts, all together called as skim milk. Face cream is a toiletry consisting of any of various substances in the form of a thick liquid that have a soothing and moisturizing effect when applied to the skin. It is mainly composed of oil, water, emulsifiers and other ingredients. A cloud is an aerosol consisting of a visible mass of minute liquid droplets, frozen crystals, or other particles suspended in the atmosphere of a planetary body or similar space. Aerosol spray is a type of dispensing system which creates an aerosol mist of liquid particles. It comprises a can or bottle that contains a payload, and a propellant under pressure. When the container's valve is opened, the payload is forced out of a small opening and emerges as an aerosol or mist. A rock is any naturally occurring solid mass or aggregate of minerals or mineraloid matter. Upon microscopic observation, we can find very small pores on the surface of the stone, which justifies that it is a solid foam. Yoga mat has layers of matte foam, which is a type of solid foam. Solid foams are a class of lightweight cellular engineering materials. These foams are typically classified into two types based on their pore structure: open cell structured foams, also known as reticulated foams, and closed cell foams. Matte foam is a type of closed cell foam. Soap lather is a foam or froth formed when a detergent, such as soap, is agitated in water. Air bubbles are formed on the surface of soap water due to its lesser surface tension. Whipped cream is liquid heavy cream that is whipped by a whisk or mixer until it is light and fluffy and holds its shape, or by the expansion of dissolved gas, forming a firm colloid. Note that gas in gas colloid does not exist. What do you think may be the reason? Well, both the gaseous components equally disperse each other homogeneously at the molecular level. Hence it always forms a true solution. Simple, isn't it? Well, this part is a bit complex and is majorly dealt with mathematics. So, Brownian motion, or pedesis, is the random motion of particles suspended in a medium. This pattern of motion typically consists of random fluctuations in a particle's position inside a fluid subdomain, followed by a relocation to another subdomain. There is a term named diffusiophoresis. It basically means the movement of a group of particles which is induced by a concentration gradient. Now you may wonder, what is concentration gradient? Simple. Concentration gradient is a situation which occurs when the concentration of particles become higher in one side than the other side. In a nutshell, Brownian motion can be visualized as random zigzag movement of particles maintaining mechanical and thermal equilibria. It is mainly observed in colloidal systems. Broadly speaking, there are two effects of this motion. First, Brownian movement causes the particles in a fluid to be in constant motion. Second, this prevents particles from settling down, leading to the stability of colloidal solutions.
In this lesson, we're going to have a look at the idea of Brownian motion. This is useful because it helped indirectly to confirm that atoms exist. You're in a darkened room, the air is still, and the bright lights are streaming through the window. What do you notice about the dust particles? The black circles as they pass through the beam of light. Pause the video and think about this. Press play once you've made up your mind. The answer is that the dust particles are moving randomly. Did you see it? The dust particles are not always moving downwards, but are moving in all directions. The dust particles are very small and are supported by a fluid. In this case, that fluid is a gas. You are unable to see the gas particles directly because they are too small, but you can see the larger dust particles. The reason that the dust particles move randomly are because of the gas. We know that the gas is there because every time we move our hand through the air, we feel them against our hand. Try it now. Continue when ready. The particles in the air move in random directions quickly. This means they will have many collisions or will bump into the dust particles many times. Each collision between air particles, very small coloured circles, show how the dust particle, the black circle, moves off in a new random direction. It's a bit like a game of snooker, where there are millions of marbles which collide with larger, observable particles like a ping pong ball. This effect was first observed by scientist Robert Brown. He was looking at pollen grains suspended in water under the microscope, and he wondered, why they jiggled around. He thought that the pollen was alive. It was later that scientists realised the importance of his discovery. Now, here's a challenge for you. Thinking about what we know about dust particles, can you explain why the pollen grains appear to be jiggling randomly? Pause the video and continue when ready. In summary, the fluid is no longer a gas, but is a liquid, water. The pollen grain is colliding with many water molecules. Each water molecule is too small to see, but we can see the combined effect of their collisions on the pollen grain as it moves randomly. This effect is known as, you guessed it, Brownian motion.